All right, can everybody hear me?
Yes, we can hear you.
All right, thanks, Kevin. Okay. Sorry for the late notice on moving it to Zoom. I think a lot of people are on Zoom anyway, but was feeling a little bit under the weather, and we're not supposed to come in then, so I just switched it to Zoom, and want to make sure that we can get through the material because we're almost at the midterm. So it'll probably be a shorter session today, and I'll just cover the final material in the binomial lattice and show you some things, and then that'll be it. All right, let me start. I'll share the screen. And then once I share the screen, we will move over to the web page and just remind you of the things we have going on. All right. So second midterm, that's the big thing. That's next week, next Wednesday. I will put information about that in an email. But very similar to the first midterm, it's going to be multiple choice. You can use one page double-sided of handwritten notes. It's only the material after the first midterm. So that is basically the material on options. So we had the chapter that had put call parity, had some option bounds, things like that. And then the binomial lattice was the big one. So that's the material that's going to be on the exam. And the plan is on Monday to do a review. Same way we did it last time. I'll see if I can get that up by the weekend. But I will plan to have just review questions, and we'll walk through those questions on Monday that are hopefully reflective of the second midterm. So we have that, and we also have a homework. And the homework, we've been going a pretty long time here on this, on binomial pricing. So like I said, we're going to finish it up today, probably pretty quickly, and then we'll take a short day. But this one is due on Monday. So I want to make sure everybody gets that in by Monday. And it's also a good review for the exam. So that is what we have going on. All right, so what I'm going to do is I'm going to jump right back into the lecture. We were actually pretty close to the end. So let me scroll down, and I'm going to pick it up where we left off last time and just remind you where that was. And then what I'll do is we got a couple of formulas and an example, and then I wanted to tie it into the Excel spreadsheet that we had, show you what that looks like, and then that'll be it for today. So like I said, probably a short day today. I don't want to push into Black-Scholes pricing at this point. We need to cut it off and focus on the exam. Okay. And just remind you of some things that we saw last time. So we saw dividends. There were two ways to include dividends into the binomial model. Doing it as a percent dividend, that's the nice way because you get a recombining lattice. And using a dollar dividend amount is probably more accurate, but then we end up with what's known as a binomial tree. It does not recombine. So that was sort of the big takeaway there, but otherwise everything works the same. And then we were down at this last topic. And the last topic here is trying to connect everything and tie it into sort of actual stocks. Okay. So like I said, we were pretty close on this. So let me tell you the idea again. So the idea is in the binomial model. Let me actually go up to where we were actually calculating a binomial model. Okay, so here was an example. So when we were calculating a binomial model, what do we have? We have some different parameters, and initially those were just given to us. Let's see if I can misread. So some of those parameters are things like the up parameter and the down parameter, and those are just handed to us. The other thing is I was giving you a per period interest rate. And what I mean by a per period interest rate is that that was the interest rate that we would use each period in the lattice. When we used the risk neutral pricing formula, we used 1 plus R, and I just handed you that interest rate R. Okay. So what we're going to do here, the final thing we're going to do is we're going to connect everything back to where would I get U and D from, and how do I need to adjust? Maybe somebody hands you an annualized interest rate. How do I need to adjust that in order to be able to use it on the lattice? All right, so let's head down and do that. And let me show you the connection, or here was the basic idea. We want our lattice to correspond to sort of actual price movement. And how do we make that connection? We imagine many, many steps on a lattice. Like I said, in practice, they will probably do at least 200 steps on a lattice. And when you do that many steps, then the so-called central limit theorem begins to kick in. And the binomial model actually begins to look like a model where the stock price is normally distributed. Okay, that's going to be our connection. That will also be our connection in the next chapter when we move the binomial lattice to the Black-Scholes formula. So that's the idea. And so what we're going to do is we're going to tie into parameters of that distribution of stock price returns. And in particular, and I'll write this down later, but our up and down parameters are going to be tied to the so-called volatility of a stock. That is how volatile, how much a stock moves. All right, that's the basic idea. Before I get to those formulas, let me remind you of what I did last time. So now I want to set up an end period lattice. We did a single period, we did 2 periods, we could sort of do stuff by hand. If I want to set up an end period, N might be 200, N might be 1,000, N might be 10. Now I need some formulas to connect things. So the first is that, what is the size of each time step in our lattice? And again, after I go through these formulas, I'll do a numerical example that'll help out. But if it's time capital T to expiration and I'm using N steps, then each little step of the lattice will be over a time period, what I'm going to call delta T, and that's capital T divided by N. So that's the first formula, and I'll highlight that one. Okay. The next thing we looked at was that interest rate. So I said that interest rate that we use in the risk neutral pricing formula is a per period interest rate. Okay. So this, how do I get a per period interest rate? Typically, if you look at interest rates, they're an annualized rate. So here the idea is if somebody hands you R, and R is an annualized risk-free rate, maybe something like 5%, 6%, then what you need to do is you need to actually scale it to an interest rate that corresponds to each little step. Okay, and so that's what I did down here in this formula. And all I did was I just equated compounding factors. So if you're going over some little step, delta T, then it's take 1 plus the annualized rate to the delta T equals 1 plus R. Delta T was T over N. And I want to pull out a per period interest rate. And so I'm going to set that equal to this right here. And then I'm going to solve for this R delta T. And that's what this formula is here. And so this is the formula. So this is the per period interest rate to use in the risk neutral pricing formula. Okay, so this is the one that you're going to use. Sorry about the scrolling. If I scroll back to a problem that we did, and we had this risk neutral pricing formula, and right there it said 1/1 plus R. What you will actually use is that R, what now I'm calling R delta T. That will be that per period interest rate. That is the interest rate that you are using there. And this formula starts with an annualized interest rate. And then converts it to a per period. And I'll do a numerical example in a minute, but let me get the last formula down. So this tells me what interest rate do I use. And the final one we're going to do here is, I call that A. We come down here, we're going to call this B. And this is the up and down parameters. So how do I obtain up and down parameters? Where do those come from? Okay, so that was the U and the D. Right. All right. So here's the basic idea. And that's what I mentioned up above. So if the stocks return over the year is normally distributed that was our model up here. That was this picture up here, right? And that makes sense from central limit theorem. So as long as we're assuming that that's our model, if the stocks return of the year is normally distributed, then U and D should be chosen to reflect that distribution. And let me give you the formulas for that. So here's the formula for U. U is equal to E to the sigma. Sigma is going to be our volatility or our standard deviation of that distribution times the square root of T over N. Make sure that that's clear that that's an N. Okay, or you can write it sigma delta T. Okay, so we have that. And then D in this model is very simple. It's just 1 over U. So we're going to stick both of these together. And I'm going to highlight these as well. All right, let me give you, actually, let me write what sigma is, a couple of comments about this, and then I'll do a numerical example. So here, sigma is what we call the volatility of the stock. Okay, what do we mean by that? So volatility is the annualized standard deviation. And that's why we use sigma. the annualized standard deviation of the stock return. And again, that goes back to the picture that I showed you before. If you have something that's normally distributed, it's got a standard deviation. And what we're trying to do here is we're trying to match with our up and down values. We're trying to match the standard deviation of the stock return. Okay. For now, I'm going to leave the discussion of how do you get the standard deviation, how do you get the volatility. So we're going to leave that for later, but we will come back to that. So later, we will see how to estimate sigma. All right, so let me do a numerical example here so you see how these formulas are used. So here's our example. So let's consider an option on a stock with a volatility, let's say 20%. Okay. So that 20%, that's the annualized standard deviation of the stock's return. Okay. We're going to say the time to expiration is, let's say, a quarter of a year. Okay, there's our time to expiration. And then let's say we look up interest rates. The last part here, if R equals 7%, this is an annualized rate. And we want to build a 5-period lattice. Okay. Then let's calculate a couple of things. What is delta T? What is our per period interest rate? And what are the up and the down parameters that we're going to use? Okay. So this is our setup. So now let's go and do these calculations. And it's basically plugging into the formulas up above. Okay, so answer, let's start with delta T. Delta T is our time step per period. Our per period time step. So delta T is equal to T over N. N is the number of steps we want. T here is 0.25 years, but we're going to break that into 5 time periods, right? So we're going to get 0.05. That is, every time step in the lattice corresponds to 0.05 years, okay? So there's the first one. Next, let's calculate the per period interest rate. Let's go back and look at that formula. So that was this formula up here. I'm going to take 1 plus the annualized rate to T over N minus 1. We'll plug into this formula. Sorry about the background noise. I'm going to go 1 plus 7%. And now remember, T over N, if I look right here, that's the same as delta T. So that's 0.05. And then minus 1. Let's see what I got there. And you're going to get a very small rate, 0.34%. Okay. All right, so that gives us our per period interest rate. And then the final calculation we want to do is I want to calculate the up and the down parameters. So let's look at our formula for that. And our formula for the up parameter is e to the sigma square root of delta t. So e to the sigma square root of delta t. Sigma here was 20%, so I'm going to use 0.2. And then I'm going to take the square root of delta t. That's 0.0, square root of 0.05. Okay, so I'm going to calculate that. And when you do this calculation, if you're doing it right, the up parameter is going to be something greater than 1, right? Because it's moving you up. So this one here, I get 1.04. And then D is just 1 over U. So that's 1 over 1.04. And what do we get here? 4.96. Right. So then once I have all these, I have the per period interest rate, I have the up and the down parameters. Then I just go back to my standard binomial lattice pricing. Okay. Because that's all we needed. We needed U, D, we needed a per period interest rate. All right, so this really ends the material on the binomial lattice. What I wanted to do, just one last thing, is I wanted to tie this in. I showed you that you can do this in Excel, and I want to tie these last steps into Excel. Okay, let me go and find, maybe you still have yours. Here was my 2-period binomial lattice. And so I just want to show you, and with the 2-period lattice, let me just really big here, but move this down a little bit. So here were the values that I started with. I started with an R, and the R that I actually use here is per period. Okay, and then we had a U and a D, and I just handed you those, the U and the D. And then we had initial stock price and strike. Those are fine. Okay, and then we calculated things from those. Risk neutral probability, we did the stock lattice, etc. So let me show you this last step. I'm going to create some room here. Let's see if I can do this in Excel and just correspond to this final step. So the final step, let's have N number of periods in the lattice, and that's 2 because we're doing a 2-period lattice. So again, I just want to connect that to the calculations that we just did. You're going to pick some time to expiration. This is going to be in years. Okay, maybe here I will do a month. So that's a 1/12 of a year. So there's my capital T. Often when you look up interest rate, you're going to get an annualized interest rate. Let's take that to be 5%. I'm just making up these numbers. And then I need the stock's volatility. And the stock volatility, maybe I'll take that to be the 20%. Oops, not 22%. Come on. It wants to do this percent. All right, so these are the things that you would really start with, okay, right here. And then what we end up doing using the formulas that we just had is we calculate the things down here. Let's do that. So what am I going to need to calculate? I'm going to need a delta T. Okay, so let me jump back. I will show you the 3 formulas that we had. calling these three formulas. But the first one is each step size is delta t, and that's t divided by n. T is time to expiration. Here we took just a month. It's always measured in years. And we divide that by, we want a 2-period lattice, so I'm going to divide that by 2. So this is my delta t. This is my time per each step. Okay. That was the first one. That's the first one up here. Let's go to the second one. The second one is I need to calculate the per period interest rate. So I'm given an annualized interest rate. I need to calculate a per period interest rate. I'm just going to use this formula. Where this here, t over n, think of that also as delta t. Let's plug in that formula. So instead of just being handed a per period interest rate, I'm going to use that formula. It's 1 plus the annualized interest rate to the power of a time step minus 1. And it's going to be something really small, right? Especially if you do a lot of steps, because it's a very short time period. So this is 0.2%. Okay, so that's just, I plugged in this formula to get our delta t. And then the last one here is the u and the d. Again, I'm not going to hand you u and d. We're going to calculate them from the stock's volatility. So let's go look at that formula. So u is equal to e to the volatility times the square root of delta t. So I'm going to take here, it's going to be e. So e is the exponential function. So in Excel, that is exp. And it was to the volatility, that's the volatility right there, times square root of delta t. Delta t was right there. And I'm going to plug that in. And that's going to give me the up factor. And then remember the down factor is 1 divided by the up factor. And there we go. I'm going to change these numbers. So now my lattices all down here that I calculated, you weren't just handed u and d per period interest rate, etc. We started from numbers like, what is the time to expiration in years? What is the annualized interest rate? How volatile is the stock that you're trying to price an option on? You got 20% volatility, 30%. What's its typical annualized volatility? And so we start with these numbers and then we go down and we calculate delta t, r per period, u and d. All right, let me ask, not for a second, let me ask, are there any questions on this? Because then I'll just show you one more thing, and then, like I said, it was going to be a short session today. All right. The last thing that I will show you is I'll just show you an example that I have that makes this sort of a little bit larger, not just a 2-period lattice, but I mentioned, you know, you could go like a 10-period or a 200. Now, I don't have a 200 in Excel. I've got a 10-period lattice here, but I wanted to show you that. So what are the inputs? So the inputs that you're typically going to start with are that sigma. How volatile is the stock? An annualized risk-free rate, right? How many steps? This I'm doing a 10-period lattice. What's the time to expiration? This one's a quarter of a year. And then I've got the stock price and the strike price. Sorry, that's K there. Sometimes the strike is also called K. And now we're using X here. Okay, so then from those, what do I calculate? I calculate delta t. That's what we just did. I calculate the R per period. I calculate the up and the down factors, right? And then once we have those, then we move on. We calculate the risk neutral probabilities. I just put a star and then there. And then those up and down allow you to build the lattice. This is a 10-period lattice. And then now I've already done this. But then I can price a call on this 10-period lattice. I started expiration, just like our steps, started expiration, put in the payoff of a call, work our way backwards step by step through the lattice. Right now, if you didn't have Excel, this would take you forever, but you do it with Excel and it's not too bad. So there's a European call and an American call. And what do we note here? These two values are exactly the same. We should have expected that because once again, no early exercise for an American call option on a non-dividend paying stock. And I don't have a dividend in here. I didn't create this model with a dividend. So when I set it up for a European and an American, should be exactly the same. And then I've got a put here. I've got a European put where I cannot exercise early. And I'm going to get this value. Again, I want to work back to that initial value, 1.807. And then I look at the American put. The American put I can exercise early. And what do I see here? It's actually slightly more valuable. 1.82, right, versus 1.81. It's almost 1.83 versus 1.81. Anyway, I just wanted to show you this is more like a completed binomial lattice model where you have multiple steps. You're starting from properties of the stock. Somebody's not just handing you U and D, you're starting from properties of the stock. How volatile is the stock? What's the annualized risk-free rate? How many steps do you want to do, etc. And this allows you to price those. All right, that was it. That's all I had for today. So I'm going to stop here. Stopping early. I don't want to push through to the next chapter because we're stopping here for the midterm. And let me just remind you again. Let me stop the sharing. Let me remind you again. So the midterm is going to be on Wednesday. We're going to do a review on Monday. It's only stuff since the first midterm. So it's basically option related topics. I'll see if I can get to it before the weekend. I plan to, bring in questions, have questions for us on Monday, and we'll just review on Monday, and then we'll be ready to hit the midterm on Wednesday. Also remember that there is a homework due on Monday. That's just this last one. All right, let's see, it's a question. Let me see if I can take a question just because we're, how to use the E function isn't working on my calculator. Make sure you're using the exponential function. So it might not be E, it might be EXP. Okay, in Excel, it's EXP. So check that, it's the exponential function. E might be, you're using that in your calculator. Yep, EXP. Yeah, then I don't know, I'd have to look at your calculator. Yeah, you should be able to do EXP and then of something. The number should, or plug in the number. Okay. All right, great. That's it. I hope everybody has a good weekend. We'll come in early next week and review for the midterm. We'll see everybody then.